Welcome to your lesson, Factoring Special Polynomials. Let's take a look at our first example. In this one, we're going to factor a perfect square trinomial. And we're going to verify by multiplying the factors. First of all, what is a perfect square trinomial? A perfect square trinomial looks like this. It can be factored to two identical factors. In this case, x plus 2 squared. Now the perfect square trinomial is actually what comes before factoring. In this example, it's x squared plus 4x plus 4 is equivalent to x plus 2 squared in this little example. This is called the perfect square trinomial because its factors are identical. Two factors are identical. So what we need to do is check if all our trinomials are perfect square trinomials. I'm going to show you a little check for yourself. So let's recopy the 4x squared plus 12x and plus 9. So what is this check? Take square root the first term and square root the last term. If we do that, take the positive part of it, which is not 3 but 2. Square root of 4 is 2. And square root of 9 is 3. Then what we're going to do is we're going to multiply these square roots together. And what you're going to get is 6. 2 times 3 is 6. Now we're going to always double this 6, or multiply by 2. And do you get 12, the middle term? If we do, then this is a perfect square trinomial. So if it is a perfect square trinomial, it is quite easy for us to factor, because the answer will be identical. And how do we find the answer? Well, we're going to use the 2 and the 3. The 2 will go here and here, and the 3 goes on the other side. And of course, don't forget the x as the variable. And the last thing we have to do is we have to take a look at the middle term and identify the operation positive and negative that exists. In this case, it's a positive. So we put a positive for both of these. Let's finish off the question. Since it is a perfect square trinomial, meaning there are two factors that are identical, it is a convention to reuse the square root. Pardon me, not the square root, but the square. So we're going to add the square. Now convinced? Let's see if by expanding this, we get the original trinomial. So let's see. 2x times 2x, I'm going to expand it, is 4x squared. Then we're going to multiply the first term by the last term. 2x times 3 is 6x. Then we're going to multiply 3 by 2x, which is, again, 6x. And the last, but not least, 3 times 3 is 9, and we're going to add the 9. Combine like terms, 4x squared and 6x plus 6x is 12x plus 9, and notice that it's identical to the original question, so we checked it. I want to show you where this 6 times 2 come from. Well, there's one 6 and the other 6, and 2 times 6 is 12 right here. So let's take a look at the second part of this question. So 4 minus 20x plus 25 x squared. Now it's been a little bit rearranged. Our middle term is still middle, minus 20x, but our last and the first have interchanged. Notice that? It's okay. It does not make a difference for us. We're still going to do the same thing. We're going to double check to see if the square roots help us to identify with the middle term. So again, square root of 4 is 2. Square root of 25 is 5. 25 is 5. And when we multiply these two, we'll get 10. If we double it, do we get 20? And the answer is yes. There's 20 right there. And I don't want you to worry about the negative sign just yet. So, this is a perfect square trinomial. That means the answer will be the 2, the 5, copy down the x because that's the variable we're using, and now just be careful of the sign. It is negative, therefore we're going to use the negative sign. And then we put the square. Let's expand it. That means we're going to multiply the two factors together. And I'm just going to use blue. And I'm going to have the red arrows and the green arrows. So hopefully by this time you know how to distribute pretty well. So 2x times 2x is 4x squared. Here's what you have to be careful about. Where do I put the x? I had the 2, I had the 5, but look where the 5 is. The 5 is with the x, so I'm going to put the x there, and the minus, and the square. So now you have to be careful. Try not to make the same mistake as I did. And now we'll expand. Hopefully this time I won't make a mistake. And okay, so again, let's distribute. Let's distribute. Forgive me for using red arrows at the bottom. And 2 times 2 is 4. 2 times negative 5 is negative 10x. Negative 5x times 2 is again negative 10x, and negative 5 times negative 5, and x times x is positive 25x squared. Don't forget that. And let's combine the like terms. 4 minus 10x minus 10x is 20x plus 25x squared. And notice that this is identical to the original question. It's a little check for us. So this is our check. Let's take a look at the next problem. In this case, we have more than one variable. This means we have two letters, A and B. Just as long as the pattern contains a squared and ab, and of course then b squared, we could factor this trinomial as any other trinomial we've done thus far. So don't let the b fool you. What we can do is we could just start with the a squared like this, plus 3, and put, once we factor everything, the b at the end. So the first thing you should be asking yourself, is this a perfect square trinomial? Well, if I square this and I square this, well, you can't really square 2 and a 3, simply because, well, you get a decimal value. It's not a perfect square. See, what's a perfect square trinomial is that if the first term and the last term are perfect squares, and when they multiply it and double it, come to the middle, then they add up to the middle, then you could factor it using the shortcut. However, this one doesn't work, so that means we have to probably do it by decomposition. So let's do this problem by decomposition. Let's get rid of the squares, roots, and use decomposition method. So again, we're going to ask ourselves, what two values add up to the middle term, which is negative 7, and what two values multiply to the multiplication of the first and the last terms, which is 2 times 3, which is 6. We ask for all the possible factors of 6, 6, 1, negative 6 and 1, and 2, 3, and negative 2 times negative 3. And those values are negative 6, negative 1. Negative 6 and negative 1. So now the negative 7a decomposes into negative 6a and negative 1a. And we copy down the other terms, like the 2a squared and the positive 3. Don't forget the equal sign. And now we factor by parts the first pair and the second pair separately. And we could factor out 2a, and we'll get 2a, pardon me, not 2, we get a minus 3, and then we could factor out negative 1, and we'll get a minus 3. Now, just on the side here in the right-hand corner, just a little recap on how do we do this. So we had 2a squared minus 6a. We divide by a greatest common factor, which is in this case 2a. We take that greatest common factor out, and 2 divided by 2 is 1. A squared divided by a is just a. 6 divided by 2, so that's negative 6 divided by 2 is negative 3, and a divided by a is 1, so we just leave it like this and close the bracket. And same thing, similar factoring for a negative 1a plus 3. We divide by negative 1 because we do not want one leading coefficient. So negative 1. Negative 1 divided by negative 1 is just a. 3 divided by negative 1 is negative 3. And that's how we factored that part. Then continue on down there. We notice that a minus 3 and a minus 3 are factors of 2a and negative 1. So we could factor that out, a minus 3. And what's left? 2a and negative 1. So 2a and negative 1. So we're almost done, except for one thing. We need to put the variable of b inside our factors. So where does the b go? Well, opposite to the a, with 3b and negative 1b. And let's see if by distribution, if we get the same answer, or actually the same question, if we expand this. So let's expand this. I'm just going to bracket for you to show you that this is the answer first. And now we're going to verify by expansion. So a times 2a is 2a squared. Now a times negative 1b is negative ab. Negative 3b times 2a is negative 6ab. And the last time we're going to expand is negative 3b times negative 1b is positive 3b squared. And combine like terms, we get 2a squared minus 7ab, because negative 1ab minus 6ab is 7ab, negative 7ab, plus 3b squared. Therefore, notice that it's the same answer as we have the question. So the question and the answer match in this case. Let's do one more for practice. Actually, you know what? I think this is good. We're going to skip B, and move on to a different type of example. There's one more special case. It is called a difference of squares. Now, a difference of squares factoring is a little bit different than completing the square. Sorry, not completing square, but perfect square trinomial. It's a little bit different. I want to show you what it looks like first. So notice the word difference. So we have to have a subtraction, and we have to have, in this case when we're factoring, two terms. And we have two terms. Excellent. We have two terms. We have difference, and now we're looking for, is it a perfect square? Are you able to do a perfect square of this? Well, the square root of 25 is a 5, and the square of, or not a square root, but a square root of 25 is 5, and the square root of 36 is 6. And the square root of x squared is just x. So both of these are perfect squares, and they can be square rooted. Since they are perfect squares and they can be square rooted, and there's a negative, and there are two terms, we can use a specific shortcut to find the factors of this. And here's the shortcut. We square root the first, square root the second, we have a minus between them, and then we recopy the factor as so, but this time we put a positive value. Wow, you must be thinking, I don't believe you. Well, you shouldn't believe me, because we are going to verify that this indeed, when we expand it, we get the original question. So let's try it. What's 5 times 5? 25. 5 times 6x is positive 30x. Now next part, negative 6x times 5 is negative 30x. And the last part is negative x squared, x times 6x, and that is negative 36x squared. The middle terms, when we combine like terms, cancel out. They become 0 because 30x minus 30x is 0. And we only get two terms, 25 minus 36x squared. And take a look, it matches our question. So we have verified it, and we'll do it one more time with question B. So let's erase everything that we have and try to do this question. So let's take a look if we could square root both sides. And the answer is we can't. We can't square root 5 because 5 is not a perfect square, and we can't square root 80. But the first thing you should always look is that, is there anything we could factor out of it? So take a look at the greatest common factors. Well, we have a 5, and 80 is the same thing as 5 times 16. 5 times 16. Therefore, we know that the greatest common factor of this is a 5. So we could factor out a 5. So let's do that. Let's factor out a 5, and then see what we have. And just for good measure, let's do it full steps. 5x to the power 4 divided by 5 minus 80 divided by 5 y to the power 4. And so it's going to be equal 5. 5 divided by 5 is x to the power 4 minus 80 divided by 5 is 16 y to the power of 4. So we just found the greatest common factor and divided by 5 because that's the greatest common factor. Now what about this difference of squares? Is this now a perfect square? That's what you should be asking us. Well, it is. It is a perfect square. Whenever you have an exponent that is, so this is the exponent, whenever you have an exponent that is an even exponent, and even numbers are 2, 4, 6, 8, and so on, then all these exponents create a perfect squared. What do I mean by this? Whenever you have a square root of x to the power 4, you always half the exponent. That means it's x to the power of 2 is the answer. For example, if you have x to the power of 6, you always half it, so you get x to the power of 3. And what do you have? You have the exponent, 6 divided by 2. So in our cases, let's just recopy the 5 factor, and x to the power 4 square root is x to the power of 2 because we're going to half it. And then we're going to do half the y as well, and then we're going to square root the 16, which is the 4. But remember, when we factor it, we are going to have 2 factors that are identical to each other, except for one thing. One is a negative, and one is a positive inside. That's because this was right here. I'm just going to do it in green. This was the difference of squares for us. And we could do that. If there is 2 terms, there are both perfect squares and there's a negative. Okay, you think you're done, but you're not, because you have to see the next line right there. If any of these can be factored, any of these factors can be further factored. Well, take a look at this one right here, and then go. And if you think you could factor this, well, sorry, you're wrong. The reason that even though both of these are perfect square, x squared is a perfect square, 4 times y to the power of 2 is also a perfect square, but because of this addition sign, it's not a difference of squares. So this is done. You cannot factor this factor further. However, you can factor this part, because it is, you could take a square root of it, and this is a negative sign. So we're going to do the difference of squares twice in this question. Mind-blowing, I know. So square root of x squared is x, and the square root of 4 is 2, and square root of y squared is just y, because we always have the exponents, half the exponents. And then we recopy it, but make sure that one is a negative, and the other one is positive addition. And then, of course, we're going to recopy the last factor that we could not factor further. And here is your answer. Now, for our sake, we are not going to expand this to verify. You just have to take my word for it. But if you want to verify it, go for it, and you will have to expand a couple times. So this is our answer. And this is the lesson.